Thanks to you all for being here. The idea is to gather a small group of people working roughly around the topic of characteristic classes from various aspects, a combination of mature people and younger people. And the idea of the meeting is not so much a conference where we will come to speak about our last year. We can do that. But the idea is more to look at the future, to see where we are, where we go. It's going to be a very informal meeting, plenty of space for discussions, and we hope we will really enjoy and profit from this meeting. And our first speaker is our dear Jean-Paul Brasselet, who is one of the leaders in the topic since its very early times. And he's going to speak about manifolds and similar varieties yesterday and tomorrow. Please, Jean-Paul.
Thank you. Thank you, Pepe. Thanks a lot. So, first of all, thanks for the Institute for having this nice meeting, and thanks to all participants. Thanks to Pepe to organize this. And I will try to enter in what Pepe asked me to do, to make a overview. But I will maybe I will insist more on returning to source, returning to the basics, and that we will see. And Pepe is hoping that there will be something going out from this meeting, and I have a very big announcement: is that we have already one result. Before the meeting, we have one result from the meeting, and, and you will see that in, as a surprise. I was myself very surprised to see that it was possible to have a result before the meeting. This will be later, and it's a pleasure for me to speak of characteristic classes and mainly chain classes. I am personally very well related to chain classes. In fact, I am older than chain classes. I was born when chain classes, Chen gave the paper to Annals of Math 3 months after my birth. So I have 3 months more than chain classes. And also I am very related to, because as you know, there have been Schwartz classes for singular varieties, and the note contributed by Marie-Hélène Schwartz was exactly the day of my 20th birthday, and so the 22 March of my exactly that day in note contributed. So that's the reason for which, for me, chain classes are something very exciting that I am very well related to. So I wanted to go back. I don't know if some of you, maybe all of you, already looked at the chain paper. In fact, it's necessary to on this one here. So this is a chain paper in 1945, and this chain paper, the founding of chain characteristic classes, there are already various definitions of chain classes in that paper, and I invite you to look at some of these definitions in the chain paper. I don't know if you already looked at it, but it is a basic. It is a founding of chain characteristic classes. First of all, Chen gave the proof of the fact that Grassmannian is how to say this, importance of the Grassmannian manifold by the theorem that you know very well, that you have here the fact that from every bundle on a manifold, bundle of complex sphere can be represented using a continuous mapping of the manifold into the Grassmann. This you know very well. And this was proved by Chen in the complex situation. That was known in the real situation, but Chen proved in a complex situation. And the first definition of characteristic classes by Chen was using what some people here use very often, the Schubert varieties. Chen proves that you can use the Schubert variety in order to define characteristic classes. And this is the way you recognize here very well the definition of Schubert varieties that some people use very often. And then this is the definition by Schubert varieties that Chen gives in the theorem. So we have this Schubert variety here, and then he gives a second method. The second method using differential forms. Chen was a differential geometry specialist in differential geometry, and he uses a lot differential forms. And so corresponding to this Schubert variety, he defined invariant differential forms, which gives a correct cocycle, exactly with the dimensions that you have here, 2n minus n plus 1. Okay, here is the number of degree of differential form. And Chen shows, Chen shows that this differential form, phi r, is exactly corresponding to ZR. This is a conical index, intersection index, between a cycle Z, zeta, and the ZR. ZR it is a Schubert that we have seen before. And you have this relation which relates the Schubert with the differential form. Okay, this is a second method defined by Chen. And then, so this is the second method. Okay, and then the third definition is by obstruction theory. Chen was already giving obstruction theory, and exactly as we know, exactly the fact that the R basic characteristic class, the R basic Chen class, can be defined exactly as a cocycle whose value on each simplex of the correct dimension, which is obstruction dimension, 2n minus 2n plus 2, that you know very well. Okay. And, it shows that on the boundary of each simplex, you have mapping without any singularity, and you can extend this, the mapping inside with the simplex with a singularity at the barycenter, for example, and this gives you and this gives you a cocycle, the quotient, which is to associate to each simplex the value, the value of this quotient. So you have a quotient which is in fact a cocycle, and this defines also the characteristic class. Okay, so this is the third definition. And you have a fourth definition, which is not so well known, and that is exactly where we will see that we have already a new result. That is the definition by transgression. What is this definition? This definition, Chen uses the bundle, the fiber bundle, but with now the fiber is a manifold of ordered sets of mutually perpendicular vectors. Okay, so you know that you can look at linearly independent vectors, or you can ask for the length between being one, or you can ask for perpendicular vectors, and this manifold is an absolute retract of with the previous one that we have seen before. And so they have the same homotopy groups. And so if you to look at this bundle over the space, so the fiber in each point is a set of R frames, okay, but with mutually perpendicular vectors. And you have a projection of this bundle on your manifold M, and you can take here the induced application on differential forms. In fact, instead of differential form, you can think of a cochain. And the same. Not the same, but you can think of cochain, it's allowed. And then the theorem is the following. There exists a 2p, 2n minus f plus 1 differential form, gamma, on M, such that if you lift this by p star, you have a differential forms on your bundle. And so p star of gamma is a differential form of the bundle, but this is a co-boundary of a differential form, beta star. So p star of gamma is the co-boundary of beta star. Beta star is a 2p minus 1 differential form on the bundle. Okay? But if you take the restriction of beta star to each fiber, this gives you the fundamental cohomology class of the fiber. This is the transgression differential form. And when I came back to the source, to the Chen paper, I said about this I know a guy who is working on things on that type, which is not the way you here are working on, but there is a guy working on this. That's Sua. And I said, I sent an email last week. I sent an email to Tatsuo, and I said, he wrote a book recently, and I said to Tatsuo, but I did not see any transgression in your book. And so he's working in Chernveil, Cheshdoram theory. So I sent an email to Tatsuo saying, but do you use transgression? And Tatsuo answered me very excited. Yes, it goes. And so Tatsuo wrote, which is, as it is a consequence of the fact that I looked at this, it's already a consequence of this meeting, that Tatsuo, as a result now, that he can write characteristic classes used in the Cheshdoram theory using transgression. And this is a new result.
But is this class for singular varieties or not yet?
Not yet. But this is a new result, consequence of this week, before the week. So it's a very nice surprise that we have already one result from the week. Okay, by Tatsuo Sua. Okay, so this is the first thing. So this is exactly Tatsuo sent me. So it's very recent, 26 October. He answered me. Yes, it goes. So we can do. And so the question now exactly is it possible to define the Schwarz-Macpherson classes by transgression? So that is maybe one question for the week. Already one question. I don't know.
Transgression of what?
What?
From where you would make the transgression on the singular space. So
Yeah.
which
Yeah.
frame boundary you would like.
There are many things to be defined, of course. Yeah. Okay. So
Are you aware of any formula for the local Euler obstruction in the context of Cheshdoram Chern-Bio?
yes, Tatsuo Sua is a big chief of this.
Then
Then
one can probably
maybe
take it
I
from
know
there.
that, but I don't know. I am not specialist Cheshdoram of Chernveil. Okay, so this is the first thing I wanted to speak about. The second one is more general, Also going back to the source, to the basics, it is many people here we have worked with Riemann-Roch theorems, can be Grothendieck, Hirsebroek, Verdier, Riemann-Roch theorems, and in fact, this theorem, some of them came as particular cases of what is well known as the Atiyah-Singer index theorem. And this is not so well known, but I think this is also something that is interesting to look at. So it is by Atiyah-Singer, it is 63, the index of elliptic operators in compact manifold. And I don't know if you are aware of this Atiyah-Singer index theorem, but it is also, I think, a very interesting result that for the moment is only known in the case of manifold. Okay. So let's just remember you that this Atiyah-Singer is working with elliptic operators. If you have two compact oriented manifold X and two smooth vector complex vector bundle, so you consider linear differential operators of the section of E, section of F, and then taking the cotangent vector bundle of X. On each, when you look at the units per bundle, on this cotangent vector bundle, on the projection P of S6 over on X, and then associated to this differential operator, you have the vector bundle homomorphism from P star E to P star F, okay, C or D, which is a symbol of the differential operator, sigma of D. And then one of the in case of elliptic operators, the kernel and co-kernel, they are both finite dimensional, and so you can define the index. The index of the differential operators is the difference between the dimension of kernel and co-kernel. Okay. This is classical for people working with differential operators. And then you use the Chern character. Chern character, in fact, we know that there are Chern character already defined in the case of singular analysis, okay, like Bonn-Fulton-McPherson. But here we have the Chern character, which is a ring homomorphism in the case of smooth manifold from the category rational cohomology to the cohomology, okay. And so you can define with your two vector bundle, you can define if there is isomorphism on a subspace Y0, you have this difference element, which is in category of Y modulo Y0, okay? And then you define this element from the elliptic operator that we have seen before, that here you have between elliptic leaf. As it is elliptic kernel and co-kernel, they are both finite dimensional. So you can define this difference element, and you take, which is in category, so you take the Chern character going to cohomology here, and by Thom isomorphism, you obtain an element in cohomology of X, this rational coefficient, okay, which is the Chern character of the differential operator. So, in the case of manifold, this is very well known and very without any problem. Then you define the third class. The third class you know very well, the third class, also in the singular case, because the third class that using the Chern, okay, to Chern roots of your bundle, Xi, you define the third class xi over the product of all chain rules. Okay, so this you know very well, and so you so you can define this third class in the case of smooth manifold, and then okay, and then using the third class and the chain character of the differential operator, you can define the index gamma of d of this is the index of the analytic side of the index, given by this formula for any elliptic differential operator. You can define this index, and then you have the famous okay. Sorry. Okay. And then so I am very bad for these things. Okay, so this is the first theorem that the index we have seen before, which is here, gamma of d, okay, is equal to the value chain of the chain character of differential operator composed with the third class evaluated on the fundamental class of x, and this is the first theorem at Singer index theorem. Okay, this is the case of manifold. Now, okay, if you have a Hermitian structure on complex manifold, then you can look at a particular case of this differential operator, which is the following. So take an homomorphic vector bundle of dimension m with Hermitian matrix, and take the exterior algebra of V. V is a holomorphic vector bundle. So take the exterior algebra of V, and then you define this G modules. G is the product of U of L and U of M. V is L is the dimension of V, and M is the dimension of your complex manifold. Okay, so you have these two G modules, and so if you take this differential operator, D, which is D bar plus D bar, is the component of the exterior derivative, and the formal adjoint, so the index of D is equal to the sum of this harmonic, the space of harmonic form of the type 0P plus coefficient in V, in W. Okay? And then you have this verbo isomorphism, c'est exact. This cohomology is the same as the topology of X modulo W, and you get this. So in that case, the ATI index theorem gives you exactly the Hirsebruch-Riemann-Roch theorem, which is a special case of the ATI index theorem. Okay, so in the smooth case, Hirsebruch-Riemann-Roch theorem is a special case of ATI index theorem. This is what I wanted to as a conclusion to tell you.
And it was the only proof working for compact complex manifolds. So
Yes,
it's about
that's
this
true.
project.
That's true. Yeah. And then already in that paper at TI Singer, they said it is natural to hope that the Grothendieck Riemann-Roch theorem for proper maps for complex manifold would be a suitable generalization as well of the theorem. This is what they write in the paper, TI Singer paper. Well, so in the singular case, we have already many things. We have already a paper by Baum, paper by Fulton, and by Baum, Fulton, McPherson, for singular, with Riemann-Roch for singular varieties. Many papers by York about Riemann-Roch theorems, various, as well as many papers by Shuji Okura. You have many papers about Riemann-Roch theorem. And you have chain character. In fact, both Fulton and McPherson, they define a chain character, but Marie and Schwarz also define chain character that is not well known, and which is different of the Baum, Fulton, McPherson, but the difference has been made evident by Michael Kleczynski, who was of nationality. He explicit the difference between the chain character defined by Baum, Fulton, McPherson and the chain character defined by Marie and Schwarz. Both. It's well the difference between both. And the third class has been defined as a singular case by Baum, Fulton, McPherson. This you know very well. So we can ask now, is it possible to, so in the smooth case, Riemann-Roch appears a particular case of the index theorem, and the singular index theorem, it is reasonable to think of index theorem in the singular case. And then obtain the different Riemann-Roch theorem as particular cases of this. So on the right hand side, it's okay, because you have already a chain character of the third class. So you know very well this index, topological index. On the left hand side, it is absolutely not what we are used to look at. So other people are looking at this. There are some approach. People working on index in the case of singular varieties. On index in singular varieties, there are many papers, absolutely not we are used to look at, but there are many people who looked at, is it possible to define an index of differential operators in the case of singular varieties? So, I don't know if some people would be interested to look at, but there are already many people who wrote this. Schulze, Stermins, Schulze, also people in Browning, Bismuth, Ursula Ludwig made also some people and Schroer in Berlin, and also Browning in Berlin. These people, they looked at how is it possible to define index of differential operators in the case of the singular variety. For the moment,
varieties are very simple there.
yeah, for the moment is conical singularities.
So maybe one can add one example which goes much further,
Yeah.
which I will mention later on,
Yeah.
which fits in your language here, is the signature operator. So the signature operator is also a special case of Atiyah-Singer, and this is completely extended to stratified spaces.
Yeah. Yeah.
Very general.
You will speak of this?
Yes.
Okay, perfect.
Just as a remark.
Very good. Okay. And it's true that for the moment, this conical singularity is, they say, the title is index problem manifold with singularities, but singularities here are also conical isolated singularities, and conical to the manifold, manifold with boundary. So all these papers are for singularities are very simple in our sense. So I have absolutely no idea. I have to confess that.
But you have to be fair, they are doing analysis. Analysis is even on these singularities very complicated.
Very complicated, very complicated. In fact, I have a long time ago I discussed even with Browning and Schroer, and I discussed also with Anacon, and my God, it's, it's a thing I was completely very complicated. It's very, very complicated. But yeah.
But I think a naive idea is that you go to the micro-local setting when you work in the cotangent
No,
bundle.
these are intrinsic views, so you don't have a micro-local. There's no ambient cotangent. They work without an ambient manifold.
Yeah, but maybe that's the problem.
No,
No,
it's not a
no,
problem.
no, no, no.
This is one choice. The
Yeah.
other is another choice. You can work intrinsically or can work extrinsically. And both could be interesting.
Okay.
But you should be say, of course, they use usually to formulate the index. You need a metric structure. So what they use is at least a suitable metric on the regular part.
Yeah, yeah.
The question is, of course, how to extend this to the singularities and so on. But this is an intrinsic view on the singular space. So what you are asking is do analysis. This is demo language, for example. You're working on an ambient manifold with singular subsets inside. It's a different
Because
story.
on the smooth part, on the regular part, you can work, of course, but what happens when you approach the singular strata? And so it's more or less related also with the problem you have with the intersection homology. When you know that in intersection homology, you can take the differential forms of the smooth part, and with poles when you approach the singular strata, and the pole, the order of the pole being related to the perversity of intersection homology. And so you have more or less the same situation, same problems in that case. And so what happens when you approach the singular strata? And for example, Anacon worked, there are papers by Anacon who are working on this, in this sense. And Anacon, for example, say that yes, the philosophical idea for people in physics is that when you approach the singular strata, there is a concentration of energy. And there is more concentration of energy in a lower dimensional strata. This is the idea of Hamilton. So you have also to, some people are also working in the sense of non-commutative geometry. So it is also not so easy way to look at things. Well, during the time I was hoping that it was possible, but I never succeeded. So maybe some of you will be able to look at these things, which are, I think, also very interesting things to look at. I think I was too fast. The last question is concerning, so I was looking at the churn at the Hasinger index, and the last question, and this is my last slide, in fact. There are many applications using minor numbers. And minor classes, they have many papers, many papers about minor classes, and many characterizations, many definitions, clear definition of minor classes. So, are there some result application using minor classes in the same vein of as application of minor numbers? So that is a big question. Maybe that would be a question we can discuss. But are there some applications of minor classes saying if minor class is like that, then that for the moment I don't know any result of that kind. Maybe they can say no. That, so there is a paper by once you're on the Hirsebroek minor class, but I don't know if this enter in this.
So this was used to show that we can characterize some sort of higher singularities that people using bidirectional geometry. There are,
So maybe it's.
and initially we used this to characterize just one direction, so more recently extended. So there are some.
So it is in that direction.
I will mention, so for me, in this picture, this has to do with measuring the singularity. So that is not application outside the world of singularities, which are also interesting. This is about these things should measure or should, it's a question how they measure the size of the singularities. This is usually not easy, but it's an intrinsic application to singular spaces. So, and of course, it depends what you mean by application.
Yeah.
Personal taste,
Of course.
and I will mention several different applications, but not for Milner classes. But I think my viewpoint on this is you compare different characteristic classes. I will mention this more general. They should measure the singularities, and the question is in which way.
Yeah. What I mean is a result of that kind. If the Milner class is like that, then you can say something on the singularity. Okay, so I was very fast. Sorry, I have to more slowly. So
I borrow your time.
So you are okay. So thank you.
So, but maybe one comment, because you are mentioning the Atiyah-Singer index theorem. So, of course, I give the classical examples in the first paper. This is, of course, the one complex, which goes to topological order characteristic, which in our complex world has to do with Chern class story. They give the signature operator, which I will mention, which has to do with L classes and which goes to singular spaces. You mentioned already the Dolbeau complex on Hirzebruch genus, I will mention. But they have a fourth example, and this is something which I miss in the singular world. I even do not know a good name of singular examples. This is, of course, the head genus for spin manifolds. So the thing is, I'm not aware of a good definition of a singular spin space. What is a good notion of singular spin space, and can you extend something of this to a singular? So that would be a question, for example, for the future.
Yeah. I think I have seen something by people in physics about this.
Yeah, maybe there are some tries, but one should, of course, not be too optimistic. These are specific examples. I think maybe we should not expect the general theory of Riemann-Roch type and what are singular spin spaces. Of course, you can take the naive definition, just say the regular participant, but maybe I'm not sure.
No, it's not sufficient.
But the thing is, this, for example, this piece of the Atiyah-Singer theorem was, of course, very important for their motivation. And this is, from the four key examples they give, this is the one which is not extended to singular spaces. The other three we extend to singular spaces. For spin, I don't know. And I will ask many questions, but spin I had not in my list, so maybe I mention it because you mentioned the Atiyah-Singer.
Okay. No question?
McPherson in the 70s had a paper about bundles with singularities.
Yes.
Did it somehow evolve?
No, it's not. It's also a paper which is which appeared in.
But what do you mean by bundles of singularities?
Generically, have vector bundle, and that is generations like an image of the bundles of bundles.
Yeah, so for example, the look of course, is degenerate loci of maps between vector bundles. So, that's a question what kind of notion. Of course, you have this kind of linear spaces. So, that is a fiber dimension can jump, and this is an anti-equivalence to coherent sheaves. So, but I'm not sure if this is used. Kind of question we are studying.
I think it is quoted in this conflict of McPherson. What is this paper by McPherson? But I don't remember about setting.
I think it was just a bunch of ideas on some conference paper.
Maybe. You mentioned already Tatsuo, so let me mention Shoji, who's also not here. I think when I get in contact with Yokora, he was dreaming of an Atiyah-Singer on singular spaces. Still couldn't answer his dream. And I think it's too much. In general, Hirzebruch, an Atiyah-Singer you will not have for singular spaces. So one has to specialize to which cases you are interested in, special properties.
In the complex, for complex manifolds, spin-C structure can be seen as a square root of the canonical class.
Yeah.
The canonical class makes sense for singular varieties.
For some,
No, well, you always have
for some mild singularities, you will have a Orenstein or something.
no, well, for those it's an integral class. But, well, yeah.
Few Gorenstein and we have a Russian class, but you need properties of the singularities. Not every singular variety has a canonical class.
Okay, but every singular variety has a dualizing sheaf. And for manifolds, they are the same.
Dualizing complex.
Yeah, but for manifolds, they are the same. So maybe that could be, I don't know.
And so,
So let's thank Jean-Paul. We start in 15 minutes.